In this lesson, we will discuss the basic formulas of integral calculus. But before that, what is integral calculus? Basically, when we take the integral of a function, this is the same as taking the reverse process of taking the derivatives of a function. Let's say that we have f of x, and we take the derivative of this f of x with respect to x. Our answer is the f prime of x. Now, taking the integral of the f prime of x dx will give us the question in the taking of the derivative, which is the f of x. But take note, try to recall that the derivative of any constant is always equal to 0. That means the integral of a 0 is always equal to a constant c. And that is why the integral of the f prime of x dx should be written as the f of x plus the constant c. And for our basic integration rules, 1, we have the integral of 0 dx, which is equal to a constant c. And for the integral of dx, this is equal to the x plus c. Then for formula number 3, the integral of a constant multiplied by a function f of x dx, we will just simply factor out the constant, that is constant k, then multiplied by the integral of the f of x dx. For our formula number 4, this is the rule for taking the integral of the algebraic sum of a function, wherein all we need to do is to take the integral of the given function individually and just simply take their algebraic sum. Then for our formula number 5, for the integral of the x raised to n dx, this is equal to the x raised to the exponent of n plus 1 all over the n plus 1 plus c, wherein our n is any integral exponent except negative 1. Because if n is negative 1, you will see that the denominator will become equal to 0, and it will give us a value of undefined. And this formula number 5 is known as the power formula in the integral calculus. Now, let's try to have problems applying these basic formulas of integration. For our first example, find the integral of x cubed minus 10x minus 3 dx. Take note that for this one, we will apply the formula number 4, or the formula for the algebraic sum, which is the integral of x cubed dx, then minus the integral of the 10x dx, then minus the integral of the 3 dx. Wherein, for the integral of the 10x dx and the 3 dx, take note, we can factor out the constant of the 10 and the 3 respectively. We can rewrite this equation as the integral of the x cubed dx minus the constant 10 multiplied by the integral of the x dx minus 3, the integral of dx. Wherein, for the integral of the x cubed dx, we will apply the power formula, which is, this is in the form of x raised to n. And this is equal to the x raised to 3 plus 1 over the exponent plus 1, which is 3 plus 1. And take note, for our constant plus c, we will write that plus c on the last part of our final answer. And for the minus 10, the integral of x dx, just copy this negative 10, minus 10. And for the integral of x dx, again, applying power formula, this x understood to have an exponent of 1. And this will be x raised to 1 plus 1 over the exponent of 1 plus 1. Then, minus 3. For the integral of dx, take note, the integral of dx is just simply x. Then, do not forget to write the plus c. Try to simplify this equation further. This will give us x raised to the exponent of 3 plus 1, which is 4, over 4, then minus 10, then multiplied by x raised to 1 plus 1, which is 2, over 2 minus 3x, then plus c. Then let's try to simplify our final answer, wherein we can write our final answer as x raised to 4 over 4. Then for the 10 over 2, that is equal to 5, we have now minus 5. Then multiplied by x squared minus 3x plus c. And this will be our final answer for the integral of the x cubed minus 10x minus 3 dx. Okay, then let's proceed with our second example problem. For our second example problem, it involves now a fractional exponent. But take note, for a fractional exponent, this is the same as an exponent of n. And we will apply here a power formula also, wherein first applying the algebraic sum formula, this is equal to the integral of x raised to 3 halves dx plus the integral of 2x dx plus for the integral of 1 dx, that is just simply the same with the integral of dx. Then, wherein for the integral of x raised to 3 halves, this is equal to x raised to the exponent of 3 halves plus 1 over the exponent of 3 halves plus 1. And for the integral of 2x dx, take note, we can just simply factor out the constant 2. And for the integral of x dx, that is understood to have an exponent of 1, applying power formula, that is x raised to 1 plus 1 over the 1 plus 1. Then for the integral of dx, that is x. Then do not forget to write the plus c. Let's try to simplify this equation further. This will be x raised to 3 halves plus 1. This is equal to 5 over 2 divided by the 5 over 2 plus the 2 multiplied by x raised to 1 plus 1, which is 2, over the 1 plus 1, which is 2, plus x plus c. Then let's try to simplify the equation further, wherein for the x raised to 5 halves divided by the 5 halves, take note, when we divide a fraction to a fraction, we will take the reciprocal of the divisor and proceed to the multiplication. And from a 5 halves, it becomes 2 fifths, then multiplied by the x raised to 5 halves, and that becomes 2 over 5, x raised to 5 halves. And for this 2 and 2, it will cancel out, and this is now plus x squared plus x plus c. And this will be our final answer for our example problem number 2. Okay, now let's try to solve another example problem. For our next example, we have the integral of the product of the x plus 1 multiplied by the 3x minus 2 dx. Take note that there is no such thing as a product rule in taking the integral of a function. And that means to integrate this product of the x plus 1 and the 3x minus 2 is, let's try to simplify this equation algebraically. That means we will just multiply them. To multiply them, just simply distribute this x plus 1 to the 3x, multiplied x with the 3x, multiplied 1 with the 3x, then multiplied the x with the negative 2, and multiply this 1 with the negative 2. And this is now the same with taking the integral of x multiplied by 3x, which is 3x squared. 1 multiplied by 3x is plus 3x. Then for x multiplied by negative 2, that is negative 2x. 1 multiplied by negative 2, and that is minus 2 dx. Let's try to simplify this equation further by combining similar terms, wherein this is the variable of x, and this is equal now to 3x squared. 3x minus 2x is plus x, then minus 2 dx. For the integral of the 3x squared plus x minus 2 dx, this is equal with 3 multiplied by the integral of x squared dx plus the integral of x dx, then minus, for the integral of the 2 dx, we can write it as 2, the integral of dx. Then, applying power formula for the integral of x squared dx, this is equal now to, copy 3, and apply power formula, this is now x raised to 2 plus 1 over the 2 plus 1. Then, for the integral of x dx, again, this is equal to x raised to the exponent of 1 plus 1 over the 1 plus 1. And for the integral of the dx, take note, that is x multiplied by negative 2. And this is now negative 2x plus c. Let's try to simplify our equation. This is equal to 3 multiplied by x raised to 2 plus 1 is 3 over 3 plus the x squared over 2 minus 2x plus c. Let's try to simplify the equation further by 3 multiplied by x cubed over 3 will cancel this 3, and this will now be equal to the x cubed, then plus the x squared over 2 minus 2x plus c. And that's it for our answer for this example problem 3. Okay, now let's try to have another example problem. Our example problem number 4, the integral of 1 over x raised to 6 dx. Take note that there is no such thing as a quotient rule in taking the integral of a function. For this equation, let's try to simplify it using algebra, our knowledge in the law of exponent. Take note, having a 1 over x raised to 6, this is the same as applying the law of negative exponent, which is x raised to the negative 6 dx. And since this is in the form of x raised to n, we will just simply apply the power formula here, wherein our n is equal to the negative 6. And this will gives us x raised to the negative 6 plus 1 over the negative 6 plus 1. And again, do not forget to write the plus c. Then this is equal now to x raised to the negative 6 plus 1, which is negative 5, over the negative 5 plus c, or we can write our final answer to be the negative of the x raised to negative 5 over 5 plus c. And this will be our answer for our example problem number 4. For our last example, for the basic rules of integration is the integral of x plus 6 over the square root of x dx. Again, there's no such thing as quotient rule in taking the integral of a function. That is why, first, we need to simplify this equation algebraically, wherein when we divide the x plus 6 by the square root of x, this is the same as the integral of the x divided by the square root of x plus the 6 divided by the square root of x dx. And to simplify this equation, I suggest that the square root of x, or this radical, let's try to write this square root of x in terms of a having a fractional exponent, wherein the square root is the same as having an exponent of raised to 1/2. And this will now be the same as taking the integral of x over the x raised to 1/2, then plus 6 over the x raised to 1/2 dx. Then let's try to simplify this equation further, wherein this will be the same as the integral of, for x divided by the x raised to 1/2, applying the law of exponent, wherein if we divide having a common base, we will just simply subtract their exponent and copy the common base, and just simply copy their common base, 1 minus 1/2, and that is equal to 1 half. That means the x over the x raised to 1 half is equal to x raised to 1 half. And for the 6 over x raised to 1 half, applying again a law of negative exponent, this is the same as plus 6. Then, x raised to the negative 1 half dx. Applying the rule for the algebraic sum, this is now equal to the integral of x raised to 1 half dx. Then, for the second term, we can factor out the constant 6, and this is the integral of the x raised to negative 1 half dx. Applying power formula, since this is in the form of x raised to n, this is now equal to x raised to 1 half plus 1 over the exponent of 1 half plus 1 plus, just copy the constant 6, and again apply power formula, and that is x raised to negative 1 half plus 1 over the negative 1 half plus 1, and again, do not forget to write the plus c. Then this is now equal to x. 1 half plus 1 is equal to 3 over 2, and this is now x raised to 3 halves over 3 halves, then plus 6. Then, for x raised to negative 1 half plus 1, negative 1 half plus 1 is equal to positive 1 half, and this is x raised to positive 1 half over 1 half, then plus c. Again, when dividing a fraction, we will reciprocal the divisor and then proceed with the multiplication, and this will become a 2 over 3 multiplied by the x raised to 3 halves, then plus 6, and for the 1 half, this will be reciprocal to 2, and this will be multiplied by 2, x raised to 1 half plus c. Simplifying this answer further, this is equal to 2 over 3, x raised to 3 halves, then 6 multiplied by 2, x raised to 1 half is 12, x raised to 1 half plus c. And this will be our final answer. And that's it for our discussion for the basic formulas of taking the integral of a function.